Hello, hello, and we're live now. Hopefully you can hear me. So, right, and let's get the code started. I'm gonna open what I had last time. I think I began to abstract the PortAudio code into some C++ classes and its own library, but I didn't finish, so let's keep doing that and see what we can get up to. Hey, let's open documentation. Let's keep it open here. Let's actually see how many people are watching us live. Right. So what did I do last time? I can't even remember where we stopped. So let's just compile this and see where we go. So, right, what do we have here? So audio.h. Pointed to point PortAudio. PortAudio is not a type. So okay, what can we do about this? I think I was gonna call this something else, the audio backend. And these are just terribly bad names for now, but we will figure out. Okay, let's just call these two functions here, the audio backend. And does it have a pointer to any of this stuff? Probably not, probably just a pointer to the stream itself. So something like this, the unique pointer here. Sorry about that. This song is not very good. Let's move on to the next one. I also want to keep track of how many people are watching this. Not many, but yeah, so let's go. It's going to be a short stream. So yeah, the idea is to have this audio backend class that actually initializes the PortAudio library with the PA initializing functions, but I also want to keep that sort of hidden from the code that will actually include this audio backend stuff. So I want to basically do a forward declaration for the stuff that I need here. So PA stream, okay. So I can't really remember very well what we needed to do to initialize PortAudio. So let's have a look. The code for initialization just calls PA initialize, grabs the error and prints it out if we need to. So okay, that's what we're gonna have in our class then. So audio backend, that's what's gonna have here. To change the name, it has to be okay, so audio backend, that matches that now. For now, it's just going to be a constructor and destructor. Wait. Right, going back to this. Okay, so let's implement that constructor. And this is what's going to be in it. And the idea is to maybe have this as a singleton as well, so that you can only have one instance of the audio backend initialized. But we'll do that in a second. So initialize it here. There is no return, so we just keep it simple for now. And also we have the destructor, and this will de-initialize the backend for PortAudio in this case. And what is the code for that? PA string destroyer, PA string callback, PA string. I'm not sure if we moved it from main, did we? Oh. We must have. Yeah, there you go. PortAudio destroy. This is the function that we use to destroy PortAudio. So I'm just going to copy what's inside there. Hey, sorry about that. Just replying to texts. And we move everything here again. Let's just put these things into classes for now. We don't need the instance. We know it's up here. Okay, so we've got a constructor that initializes PortAudio, and obviously in here we include PortAudio. Illegal type of use void. PortAudio destroy. Redefinition multiple initializations. I don't understand what's going on here, but we will have a look in a bit. Okay, it's disappeared anyway. So let's actually turn this into a singleton for now. I know it's not the best thing to have a singleton in your code, but do I keep this private as well? Can't remember. So if we do a static unique with shared pointer, and we've got those in there, and we've got a shared pointer here for the actual audio backend. Old instance. And I believe that has to be a static as well. Right? Do I have memory? I do. Okay. And the stream. Okay, so what we do now is those will stay the same, but we do have a static function called audio backend. It returns an STD shared pointer, right? I believe. Is it called get instance? I can't remember what I called it. Okay. Yeah, get instance will return now. So what we need to do is check if the instance is already up. And then obviously we return that instance. If not, we will create a new one. Yeah, that's it really, right? Okay, that should work, hopefully. Now initialize PortAudio. We've already got that in a constructor, and we remove this from here. Now we do have a stream, but I feel like it's already in. Yeah, I've got a class that will construct and destroy the streams. right? I see. I'll explain what I'm doing in a second. So this is all the stuff that I'm going to be using to wrap this string pointer into a nice little class for us. I'm not sure if I'm going to have to wrap this thing as well, but you know, it's always good to have it here anyway, until we need to get it out of the anonymous namespace. So the anonymous namespace is going to make sure that everything that we include inside this will only be visible inside the CPP file, if it makes sense. So like, yeah, these types won't be leaked anywhere else. It's just going to be visible to this compilation unit. And from what I understand, the compiler can actually inline things better, or in a better way, because it knows that these particular definitions or functions here are only visible in this particular file. So that's why we use anonymous namespaces for sort of helper functions or things that you're only going to be using in a particular CPP file and not expect. Okay, so let's begin wrapping this stream class, or wrapping this stream pointer here. So yeah, we have that. How did I wrap this stuff here? Unique pointer of stream, and that's in the audio backend. What I can do is I can just do an old style C stuff for now. So what I can say is that there is something called PA stream, right? Let's take a look at what the PA theme is. Of course, it's a void star. Pointed to a stream is a void star, isn't it? So incredible. So right, what can we do here in this class definition? We can just leave it as the string pointer, sort of a unique pointer to void star. Does that work? I've never actually did a unique pointer of void, to be honest. But let's hope it does work. So leave those there. And we've got start stream, and we'll probably have a stop stream as well, right? We are going to have a few functions to make the stream that will return a stream pointer to us or something like that. Okay, so let's get started. So I've got the audio backend stuff here, shared points for audio backend, syntax error, missing this before. What am I missing? What am I missing? Let's just refresh IntelliSense. Okay, nothing. I'm not missing anything at all. I mean, since we've already got our constructor, it would be nice to basically wrap all of this, sort of create default stream function into the constructor, right? So this is what we're kind of gonna do. Something like this. And let's put it all in the constructor and see what we actually need here. So for example, we will need the data, the data type, and again the data type is something that we included here, so the PA string data. So yeah, this might in fact be, well, it will need to be exported, as we will use that elsewhere. So we want to put the data as an input here. In itself, and the PA test callback, right? And this callback function, what is it? Okay, so it's a function that takes all of these things here. So yeah, okay, we'll create that in a second. Yeah, I mean, let's try and do that. So it's a PA string data, and you'll probably take the pointer to that, right? So the data itself. And then we're gonna have the callback here. And this callback has to be that function that will be called back to generate the streams all the time for the audio. So let's define that in the header. Obviously, this will have to be in the header as well because we're exporting it now. So luckily, it's already here. I didn't realize that. So here, what we're gonna do, we're gonna need a, I think it's a PA stream data or something. And then we're also gonna need the callback, right? The audio callback. And we're gonna, you know, define that now. Let's show you. The callback has to be that particular type that PortAudio expects as a callback, right? So let's figure that out. In fact, the best thing to do is just to copy this and then just use this to create our sort of function pointer here. So what we can do is just remove all of that. Actually, it has to return an integer. It will be a function pointer that will take all of this, and that is it. Okay, cool. So yeah, let's style this a little bit better. Okay, so that's our callback type. And now we have this defined here, okay? So these are all the things that go into making a audio callback and a callback function. For those who don't know, is essentially what this library PortAudio will call every now and then to create or to generate that audio stream data, so your actual sort of sound waves, and it's what's going to pass the data into the device itself, so into your speakers or into, you know, headphones, whatever your audio device currently is. That callback is going to generate all of that. And there are certain things you have to be aware when running the code in these callbacks, such as, you know, you can't really run things like mutexes or things that will take an undeterminate amount of time to finish. But that is what we can get, you know, into later. So for now, let's just make it compile and generate a few sounds again. We will get there. So the actual code to create a stream, I think I already put it here. Okay, cool. So data is there, the stream info. We don't return anything anymore. What we do is we do actually set, instead of this, we're going to set the actual class. In fact, I mean, I know we're doing all of this and whatnot, but what we can do is we can just get a function here that was creating the default stream, put in the anonymous namespace, and use that in the actual constructor. Just for now. That does mean we can only have the default stream ever, like being created for us, but at least it's just some ease of use here, because what we can do now is, you know, remove all of this from here and then actually pass it in here. So I think it was called stream. There you go, PA stream, that's what it's called. That will be the create default stream. And however many number of input channels, we have 0, we have 2 output channels, and we have sample rate of 44100, the standard CD sampling rate, and then the data itself, which will be there. What we don't have is a callback though, so this function is not actually taking the callback here, which is something we can do. We can take the callback there, and pt3 callback, we can just use the callback there. Okay. Now do notice, however, what's going on here? Here data, what did this? Oh, it doesn't take the data. It takes reference to the data. Yeah, just put a pointer there for now. Okay. What was I gonna say? So yeah. Do notice that this may return nothing though. In fact, yeah, it returns a unique pointer to a stream, so we don't want that. What we do want is a shared pointer, I believe, right? So pointer, say, oh, shared pointer here. And how do you pass the destroyer to the shared pointer? So I can't remember the syntax very well. Okay, we can just pass the deleter into this. Too many arguments. Okay. refresh, IntelliSense. Do we want a shared pointer? We just want a unique pointer. I think a unique pointer would be good, actually. We don't need the string to be shared pointer, do we? Only one person is ever going to own this, and that person is the string class. I will take a look why this is not building. Yeah, string callback info. Ah, I know why. It's because of the struct. Okay, so let's go back into this and put all the 4 declarations are at the right top. So okay, so that's going to for declare it, which is fine. And this is also, I believe, a struct. Signed. Unsigned long, okay. Unsigned long, so let's do that. This will actually be right here. Okay, cool. Some errors have disappeared. We have a create default stream for us. PA stream. We just don't have that destroy function, which is the function that's actually going to destroy that bit of memory, that pointer. Where did it go? Let's figure out. Okay, so we do have it here. PA stream destroys this one here. Let's just put it up here. Okay, now there should be no errors there. We did create this code before, by the way. This is what actually destroys the PA stream. And it seems to compile a little bit better and up until all of it compiles actually, so. See, we don't need these anymore because we have essentially what we had before is like a unique pointer that was actually managing or handling the lifetime of a PortAudio instance, even though there's only one instance ever. So when you create it, for example, you would create us, or you would initialize the PortAudio library for us, and when it would be destroyed, so when the destructor of that unique pointer gets called, it would destroy or stop PortAudio completely. But we've essentially done that in the audio backend now. So if you take a look at that, that's exactly what we do in there. Hopefully, right? Let's have a look. So we've got the audio stream stuff here, and then we've got the stream there, which obviously we still need to implement the destructor and the stand stop. But in the audio backend, we initialize it here, and we also deinitialize it in the destructor of audio backend. Okay. So yes, in essence, we don't really need these points or definitions anymore. Initialize PortAudio is no longer needed as well. This audio callback, I'm actually going to leave it in the main function because it's not going to be part of the library itself. We're just going to put it here for now. This is something we link into later on when we actually create the PortAudio instance on the stream. So yeah, let's just finish these two classes. We have the stream here. There was one thing I wanted to address, which is the case of the function that creates the stream returning a null pointer, essentially. So in that particular case, we can't start and stop the stream. So what would be nice for us to provide is a way to check if that stream is valid, for now at least, because that's something that we may need in the future. And that is just going to check that the stream is valid by looking at the pointer that we hold. And stopping the stream would essentially mean running the stream destroy function. Oh yeah, we don't even need to do anything because, look, if you take a look, this stream is already a pointer, and this pointer, this unique pointer has a custom deleter, and that deleter itself is the PS or PA stream destroy function that we created previously that already handles the PortAudio stream delete stuff, or the close stream. So yeah, I mean, all we really have to do is just, in fact, we just remove this this destructor. We don't need it. So now we can take a look at the isValid function. So let's do that. I love it when my Visual Studio Code goes down. So this is what happens. We just check that the pointer is actually valid inside. So if it is, then this function is valid, it's going to return true. In other words, if it's not a null pointer, we return true, and false otherwise. And this is where we're going to start the stream, and we're also going to do a function here to stop that stream. And these functions are already created for us. We have stop stream, start stream. So this is the start stream. Then in here, if the PA stream is no pointer, or in fact, we can just check that is not valid here. Here we just swap that to a dot get, and it should work fine. The rest is absolutely the same, and it's the same thing for the stop function. Okay, logic is exactly the same for both of those functions. Now we can obviously delete these two functions. Don't need them anymore because they're being done somewhere else. And what do we have left here that we haven't implemented yet? We're not leaking anything from PortAudio so far, which is good. And we have the PA stream pointer there, and that itself is a unique pointer. So the stream owns a unique pointer to a void star, which is the type PA stream, I believe it is, right? So we kind of like a for declarations, a bit hacky because PA stream is actually a void star, which is, you know, basically a pointer to anything, but it's a way of basically putting that in a smarter structure, unique pointer. And I do hope that unique pointers to void stars work, though. I'm not entirely sure they do, you see. Maybe that's something we can look up. Do unique pointers work for void? Let's have a look, because it might not actually, and if it doesn't, we're kind of screwed. I mean, there's a Stack Overflow here saying, why does shared pointer implement type erasure? So apparently unique pointer void is ill-formed, but why is that? It's because shared pointer implements type erasure, well, does not. Okay. It does not need the type of deleter as a template type argument. The class template. Look at the declarations, which has a deleter. That is cool though. You can save any object as void star and the shared pointer and it still can find the correct constructor for it because of type erasure. The type of the deleter is not passed as argument to the class template, which means a little bit of freedom without compromising type safety, and that is good. But the thing is, I'm using a unique pointer with a custom deleter, which I explicitly pass into it. So does that, because that essentially knows what function is going to use to delete the void star. Therefore, I'm wondering if it's still safe to do that. Because for now, we're really going to do it, but we need to have a look at it in the future, to be honest. So what I'm saying is maybe, you know, maybe take a look here. To make sure it's safe. But yeah, regardless, you know, we're gonna do that. Okay, so all the errors are now in our main function. And by the way, because we've correctly, well not correctly, but we successfully wrapped all of the PortAudio in its own library, we're going to remove that class, and what we're going to do here is, well, we're going to have this callback still in here. Ooh, I see. We still need one of the types from. Okay. We're going to deal with that in a second. But yeah, all the other stuff. Yeah, so for example, also for audio, it's going to be the audio backend, I think it is. And obviously we need to include our audio library in this project. Oh yeah. And it was a singleton, so there you go. We do have essentially a way to create a singleton audio backend. I know it may not be the best thing to do right now, but we're gonna go with this. And once this reference goes out, I'm not sure what happens actually. I realized that, you know, what happens when this is destroyed? What happens when PortAudio is no longer reference? Because essentially because it's a singleton, that unique pointer is still going to be here or there. I mean, we could do something like, you know, once that pointer goes out of scope and the reference count is C1, right? So then we delete it, right? How do I get a reference count? Sorry, I think it's use count, right? It returns a number of different shared points when instances this included managing the current object. If there's no managed object, 0 is returned. If in a multi-threaded environment, the value returned by use count is approximate. Typical implementations use a memory or delivery lax load. So really, use count is 1 here, and if that is exactly 1, meaning that there's only this instance that has now, you know, been returned, we can delete it, and it has to be done after, you know, all of this, because, you know, yeah. Or no, or maybe should have wrapped this in another another pointer. I am now very confused. Okay, no, I think we're gonna need a custom deleter for this. Okay, so we're just passing the deleter afterwards. It doesn't need to know the type of the deleter, unlike unique pointer. So what can we do here? In the creation, where is it? Yeah, in the creation of the get instance here, we create a new audio backend. And the deleter, let's say it's going to be an audio backend. You know, if we say if the instance dot get I'm getting confused massively. This is why you don't do singletons. It just makes you very confused because I return a shared pointer from it, but there's no way of that shared pointer being sort of deleted now, because there's always going to be one shared pointer here in the instance, you see. What I could do is, you know, put it as a unique pointer, but what would that change? Because it's still the pointer allocated by the class itself. So maybe this class needs to be changed, you know. Maybe I don't actually need this whole class. Yeah. I'm now debating what to do with this. It definitely needs to own a stream though. See if I can get something down really quickly. What do I actually want? What is my use case? My use case is to have some sort of object that represents the audio backend, such that when I create it, it will initialize PortAudio, and when it gets destroyed, it will deinitialize PortAudio. I mean, in simplest term, it is just a little struct here, really. And then a function that will return just the function that just returns the audio backend. I know I've gone around in circles now, but that's what we're gonna have. Gonna have the audio backend once here. Gosh, I can't spell today. Yeah, so let's keep it as this. And we can just get rid of the singleton stuff for now because that's just complicating the code. A typical scenario where you think you need something but you don't really, and it just ends up complicating the entire code. Audio backend. It should be here. Audio backend is okay. There you go. Now we need to convert all the stuff that we had previously. So, you know, this is what's going to create the instance. So, let's see. empty. Just an empty shit here. Else we're gonna return. Just getting this to compile, then I'll stop this stream. We're doing the string there, don't we? And in here we actually need the constructor. There you go. Or we can just align it here as well. Okay, we're back. Okay, so the stream do a needs a data and a callback. Okay. Okay, so that does work. And then we can move stream now, right? Simply there you go. It should somehow compile. this type here is being complained about. I'm gonna leave it here. Figure it out tomorrow. Bye.